Hi, and welcome to Autodesk Eagle Online Workshop. Today we're going to be featuring the BeagleBone Blue. My name is Ed Robledo. I'm part of the Autodesk Eagle support team, and with me is George.
Yeah, I'm George Garcia. I'm an Autodesk support specialist for Eagle.
Excellent. Thanks, George, for joining us. And our guest of honor this afternoon is going to be Jason from the BeagleBone Foundation. Hey, Jason, can you tell us just a little bit about you?
Sure. My name is Jason Kridner. I'm an employee of Texas Instruments for 25 years now. Some time ago, we started up BeagleBoard.org, and I'm now a board member at the BeagleBoard.org Foundation. And I do a lot of the community interactions, and I'm the only board member that's still currently a employee of TI, so TI donates my time to this project. So I pretty much have the dream job, and I'm happy to kind of share the tech we've been able to put together with you today.
Excellent. So we know that you have a lineup of the Beagle Bones, and I think you're going to be going over an overview of it. So I'll let you take control. What's going on?
All right, let's go ahead and start flipping through some slides. This first of all, you'll see quick a picture of the BeagleBone Blue, but we're going to tell you a little bit about how we got there. So BeagleBoard itself, started out based on mobile phone technology, right? So using ARM processors that are really low power consumption processors, so they're able to run off of batteries efficiently. Because they're designed for cell phones, but TI took that processor and put a bunch of industrial peripherals around it, making it really well suited for doing things like robotics and a lot of other really cool applications. But we're going to really focus on what you can do in robotics. And You're able to develop with all of the BeagleBones using a single USB cable, right? So you're able to power them over USB. You're able to do the development and debug, get a network connection, and work them entirely over USB cable. Of course, now with the BeagleBone Blue, it's really exciting is that it has a battery connector directly on it for a rechargeable battery and a 2-cell LiPo battery. And you can plug one of those in and really put it on the go, right? So just run off of battery. For doing that development over the USB cable, with the BeagleBone Black, with the number of the BeagleBones, you can plug in keyboard, monitor, and mouse and kind of use it like a desktop computer. That's really not the vision for BeagleBone. For BeagleBone, our idea is that you're going to go and make electronics, right, electric systems, and make them more like appliances rather than looking like computers themselves. So you really want to be able to work with it remotely, so it's actually in the system and you can still do your development and debug. So we ship with a Debian Linux distribution on the boards, and we include the Cloud9 IDE that if you're seeing the screen sharing, that's actually Cloud9 IDE that's running on the BeagleBone that's showing on that shared my shared desktop, right? So you can actually develop and write your code, get to the Linux command line, edit text, and do everything directly within your web browser, right? So that's actually what's showing here on my desktop. Let me just, where's my mouse cursor? There we go. Just to highlight there, this is actually just running in the Chrome browser, right? It's nothing special, just a Chrome browser opened up to the address of my BeagleBone Blue. There's some really cool peripherals. I said that these processors were built for industrial applications, and there's some really cool peripherals, specifically some microcontrollers in there. They're called programmable real-time units. They're 200 megahertz RISC processors that are really good for doing hard real-time coding, even creating software peripherals, doing real-time control aspects, and other peripherals like hardware pulse width measurement, as well as pulse width modulation, generators, PWM generators. Lots of hardware that offloads the main processor and allows things to happen in real time, right? So things that if you were trying to bit bang it would really just chew up all your CPU time. And so we have a lot of capability for offloading that stuff in all the BeagleBones. And we've grown over time here, right? So we started with the original BeagleBone back in 2011. In 2013, we introduced the BeagleBone Black, which was is really the most popular board in the BeagleBone family. And we have two fairly recently released boards: the BeagleBone Black Wireless and the BeagleBone Blue. So let's walk through those. Okay. I want to just and also, right, this is a rich ecosystem. So those are the BeagleBones that we've created at beagleboard.org, but we're an open ecosystem allowing other people to go and build variants of the BeagleBone, and these are the ones that utilize the BeagleBoard compatible logo. So Seed Studio has the BeagleBone Green, SandCloud has the BeagleBone Enhanced. We have NeuroMecha with the BeagleBone Air. GHI with the OSD 3358 dev board, Montreal with the Musamic, both Aero and Element 14 both have their own variants of industrial temperature-rated BeagleBone Blacks. So there's quite a few different options out there in the ecosystem for people to look at. You can find more at beagleboard.org/logo about those individual boards. But let's go through the history. So we started with the original BeagleBone back in 2011, and it was originally, so it's built around an ARM Cortex A8, originally at 720 megahertz, and it moved forward to 1 gigahertz after the initial release. But there's a number of different CPUs within this processor family. So of course there's the ARM Cortex A8, which is the main one that's there for running Linux, superscalar, running 2 instructions per clock cycle, and it's got a vector floating point unit, Neon accelerator. So that's the main CPU. But in addition to that, we have a Cortex M3 in there that's primarily used for power management and security functions. The firmware that we load and boot up is shared as open source, and everybody can look at what that firmware is and modify it to change what that M3 can do. And it can go out and touch the different peripherals in the system in order to. But generally, it's used to put it into low power suspend modes. It goes out and re-enables the different peripherals in order to bring it up out of reset, so you can continue execution of your code. Or if you need any type of security co-processing. There's also, this is one of the key features that everybody uses a BeagleBone for. It's those 200 megahertz RISC programmable real-time units. So those are highly optimized to be really low latency to all the to a set of I/O pins. And you can essentially just a single instruction modify the pins because they're directly mapped to registers on those programmable real-time units, right? So you can directly bit bang things out. There's also some shift register capability and some in some of the peripherals that are sitting around those programmable real-time units. So they're really great at creating software peripherals or doing any of the low latency, hard real-time stuff that you might have in your system. There's also a 3D graphics coprocessor in there if you wanted to do anything. We find that's kind of useful when people build 3D printers, want to do some visualizations of the 3D prints before they print them. Other different things where you're trying to do some 3D rendering. We've got that capability in there. So the original BeagleBone included 256 megabytes of RAM and a micro SD card slot where it would run off whenever you put the image on the micro SD card, it would run directly off of that. And for connectivity, we had a USB client port with built-in hardware, USB to serial and USB to JTAG adapter built onto the board. So when you plugged it in, you could actually get to the low-level I/O and actually do JTAG debugging over that USB port, right? And actually do stop mode debugging where you could where you could actually probe. So there's some support within OpenOCD as well as within TI's Code Composer Studio for utilizing that debugger. There's also 10100 Ethernet and USB host support. So it's a high-speed 2.0 host. There's also the introduction of the 46-pin CAPE headers. and a library of different capes that have been released. So well over 100 capes have been released out there, and a large number of them open source. Availability varies depending on the board, but for the most part, you'll see different distributors will have different capes that they really support. And on those cape headers there's 65 digital GPIOs, there's 7 analog inputs, there's 8 hardware pulse width modulators, 4 timers, 4 UARTs, a couple of I2C ports, a couple of SPI ports, the QEPs or the quadrature encoders or pulse width measurement, and a whole lot more. In fact, all of the digital pins have up to 8 different functions that can be muxed out each of the different pins. And so it really provides a lot of flexibility for what can be built on that. And so that was the base that all of the different BeagleBones have been built on. So that's the original. So I want to spend some time there just because we're going to leverage a lot of those features as we move forward, right? So with the BeagleBone Black, was first introduced at 1 gigahertz, so it was always 1 gigahertz. There was the white moved from 720 to 1 gig. We increased the RAM on the board from 256 to 512. So all BeagleBone Blacks have 512 megabytes of RAM. But one of the things that the low-level debug was great for most people. They just want to boot into Linux and just do development there. So it was that USB to serial and USB to JTAG was both consuming power as well as board real estate and some cost. So we removed that not heavily used feature, but we added 2 features that people made really a lot of use out of, and that's eMMC flash storage. So it's more reliable than running off of a micro SD. It's higher bandwidth. We can get higher quality, better throughput using the onboard flash versus using the micro SD cards, which we found to not always be the most consistent and reliable. Initially, BeagleBone Black came out with 2 gigabytes of flash, and it moved to 4 gigabytes of flash. And there's also a micro HDMI adapter, so this allows you to actually connect up monitor with audio, so you connect up a TV to the BeagleBone Black, whereas the original, the white, did not support connecting that. So there's a micro HDMI connector on the BeagleBone Black. So the big thing for users, why it's so much more popular than the original, is because both the price and the static power consumption were dropped. So this is still the most popular BeagleBone, and as of the last sales report I got in March, the distributors and manufacturers making these are actually selling more now than ever. The popularity, even since 2013 when it was launched, it's more popular now than it ever has been. So it's people are continuing to find new uses for it, and we're pretty excited about that. So we tried to do some things to really make it more accessible to people doing variants of the board, and that's why we've now worked with Autodesk Eagle to convert. So we took the original BeagleBone Black design. We worked with Octavo Systems to create a system and package that took over 150 components on the board and put them inside of a single system and package, removing the need to do any sort of high-speed layout or any the complicated, and just drastically simplifying doing board design around the BeagleBone. And so we migrated that BeagleBone Black design from OrCAD into Autodesk Eagle. To release that board, we also made one other significant change here in the BeagleBone Black Wireless, as we swapped out the 10100 Ethernet for onboard Wi-Fi and Bluetooth. That's it's 802.11n support, of course, including B and G. Access multi. We can run multiple virtual network devices with that. Including, so when you power up one with the latest images, it'll actually come up as an access point, and that's a good way to log in and configure the boards. And then there's Bluetooth 4.1, Bluetooth low energy support on there, so you can do Bluetooth operations as well. All right.
So this was also the first one that was made in Eagle, right? The
This
black
is
wireless.
the Black Wireless is the first one. That's where we made that migration from OrCAD to Eagle. So that was the first one done there. Exactly.
And just to let everybody know, I think the Black Wireless as well as the BeagleBone Blue is already included on the default install, so you could see them there as well.
Yeah, that's fantastic, right? It was, our approach is somewhat different than some other people making Linux systems, single board computers, affordable single board computers. That we really want people to clone it, right? We want there to be an open ecosystem, and so we do everything as open hardware, and we think using Eagle is a great way to go out and reach a broader community of users. And allow people to make different variations. So working with Octavo systems to create the system and package, simplifying the design, and using Eagle. So this is the first of those reference designs that were released. And so you can go and easily get BeagleBone Black wirelesses from major distributors today. And of course that was the basis. So the history of the blue actually goes back to the original BeagleBone Black. So originally the folks at University of California, San Diego, in particular James Strawson, developed this thing called a robotics cape, and that was originally done with the BeagleBone Black. And there are hundreds of students. I think at last count something along 600 or 700 students have built robots using the robotics cape. Plus either BeagleBone Black or now a BeagleBone Black wireless. And so they've gone through multiple revisions of that robotics cape, and they're now on the fourth revision. And we're actually working on getting that released as a standard BeagleBoard.org product that's not out there public yet. But we're working on making that available for people who already have BeagleBone Black or BeagleBone Black wireless. And it's supported by James's software library called librobotics cape. It's a C library with lots of examples for the major functional operations. And it's worth some time to go through the features. Make it really clear later, right? Because the BeagleBone Blue is actually based off of this robotics cape, right? So all these features are ones that we're going to leverage on BeagleBone Blue, including support for a 2-cell lithium polymer battery, including balancing and an LED gauge for looking at the charging status. It also has overvoltage and undervoltage protection. The input is anywhere from between 9 and 18 volts in order to provide the charge for your 2-cell LiPo battery. It's got 4 DC motor outputs and 8 servo motor outputs. Right, so depending on what you're using, if you're looking at the screen, right, so this is a tiny servo. Of course, it can drive some bigger stuff than this. But it's designed for driving standard 6-volt servos. I just got a tiny one here for demos, and then things like this geared DC motors. Right, so those are the types of motors that it has built-in support for. If you wanted to build something like a quadcopter. Generally, you'd use these servo motor outputs. You can actually use them to feed electronic speed controls for building quadcopters. In fact, there's already support in the open source project ArduPilot for building quadcopters. You can just simply install ArduPilot and build a quadcopter, and all the software's there. There's also quadrature encoder inputs. There's 4 of those. The hardware in quadrature encoder inputs, there's only 3 of them. So the 4th one is actually implemented as pure use software, and that's a standard firmware load that comes for use with the robotics cape and on the BeagleBone Blue as well. Also integrated are some sensors. It's called a 9-axis IMU. Happens to be the InvenSense MPU 9250, but that's the thing that allows you to to tell your orientation. It's a gyro, accelerometer, and magnetometer or digital compass, and also barometer. I see some comments about loving the 9250. This is really one of the all stars with on the robotics cape and on the BeagleBone Blue. Right, it's a really great high-end hobby grade sensor. Along with the Bosch BMP 250 barometer. And then for the expansion connections, in order to kind of make it easy to build these robots in enclosures where you want to do point-to-point wiring instead of have to do another breakout board, there's the JST connectors for doing quick connects to the I2C, SPI, UARTs, CAN, GPIOs, the GPS connector, DSM radios, and other components. And there's also some additional user programmable LEDs. There was a question live, I might as well answer it. The DSM2 radio is not on board. What there is a standard connector for the satellite radio receiver. So no, it's not that the DSM2 or the GPS is on board. Yep. So now let's jump to the blue, right? So let's get into it. So the BeagleBone Blue is the BeagleBone Black wireless and the robotics cape combined into one board, right? So you'll see that the cape expansion headers are gone on the BeagleBone Blue, and that's because all those resources have been used through the robotics cape. So that's the combination. A lot of the reason to do the BeagleBone Black wireless is kind of that stepping stone, because we didn't want to have to do wired Ethernet for robotics device, right? We want this thing to be wireless. So we needed to do the BeagleBone Black wireless first, and then integrate that with the robotics cape. We actually managed to reduce the number of layers. This is only a 4-layer PCB. All designed in Autodesk Eagle. Let me tell you that I think that's a pretty impressive feat. Having the system and package is part of what makes that possible. Getting all that integration into one chip. We put a lot onto this one board. I think it's fairly impressive. Anyway, so all those combined, a simpler design. We think that's something pretty good reference for people to take, and actually, if they wanted to do to modify it, the BeagleBone Blue is in mass production today. There are literally thousands of them that you can go and get from currently 3 major distributors: Arrow, Mauser, and Element 14, with other major distributors coming online soon. So we launched with a lot of boards because we know this is going to be really popular. What are the nice sort of side benefits of having, without the cape headers on here and everything's kind of integrated and set to individual functions, is it really simplifies the system configuration. Right, so there's no need to go and mess with the pin muxes to decide which function what do I want out of these pins. We've kind of set them for you, right? So the UART is always a UART, right? The GPIO pins are always GPIO pins. The I2C is always I2C. The SPI is always SPI. So we define those ahead of time, places where you plug them at for the most common uses of those interfaces. Yes, it is still possible to change them, but we made the defaults just work. So greatly simplifies system configuration. All the people, if you used BeagleBone Black before, you've heard of Cape Manager, you've used it, right? It's not something that we enable by default on the BeagleBone Blue, right? Because it's all just fully integrated. We also did.
Okay.
Go ahead. Yeah, go ahead.
Sorry. So on the Blue, it's device. You could use device trees to reconfigure the pins if you wanted to. If you wanted to get into
you can modify the device tree. You could even try to do. You could even do overlays. But the Cape Manager, So there's a few different components to configuring the pins in a device tree system. So there's a device tree that you get at boot that describes the system as it is. There's a mechanism called overlays, which allows you to modify the running device tree to change that system configuration. And then there's Cape Manager. Cape Manager actually sits on top of that. What Cape Manager does on a BeagleBone Black, a BeagleBone Black wireless, is it goes out and reads an EEPROM that's sitting on that cape, and it has a name of the cape, and it looks inside of its system for an overlay and automatically loads that overlay. So Cape Manager is the system tool that performs that triggers the overlay. So the kernel, you could do overlays on it. There's also something that you can put into device tree that's called a helper. So you could actually load possible different options into your device tree using a helper function, and there's a pinmux helper, and so you can use the directories of the pinmux helper. And I could show some of this on the. I think it's worth a few extra minutes if we have it. I know I'm pretty much already close to time, but
Now,
we can.
yeah, we're fine, Jason. We're fine.
All right. So I can actually show you some of that as we get into some of the software. I probably want to push that off to a little bit later, but where you can actually go through and utilize pinmux helpers that have been put into your device tree to go and change those pinmuxes without ever having to load any additional device tree, right? So you don't have to do any overlays in order to go do those. So if you can predefine those different modes that you want to be in, and the terminology we use in the BeagleBone Black land is what we call the universal overlay. So the universal overlay is a device tree overlay that's been loaded at the beginning, but it includes all these helpers that you can use to just go into different files and change the pinmux settings without having to actually load the device tree overlays themselves manually. Device trees are fairly complicated. The good news, I want to go back to that good news here as I open up a little bit of Pandora's box, right, is that the BeagleBone Blue, you just don't have to worry about that. The configuration is done, so you can just use it as is. I saw some nods to the CAN bus, right? So we've one of the additions from the robotics cape. So the robotics cape had a way to get to the CAN, but we actually put the CAN PHY. I'm not sure if the latest robotic tape included the CAN PHY or not, but anyway, we do have it on the BeagleBone Blue. So you can actually just you wire into a CAN bus, which is really great for some of the higher power motors, talking to those or talking to other systems. If you want to interface with automotive things, so it's a really handy feature. Nice for really reliable networking, even between some maybe different boards in the system. Here's the eye chart. This one is mostly in here for your reference because this is essentially all those details that we've discussed kind of thrown into just one slide, right? Just summarizing it, right? But we built it up, right, from the white to the black wireless and the robotics cape and adding that in to make the BeagleBone Blue. This just kind of summarizes all that for you. This is also kind of handy reference where I don't know if you could see mouse. You can't see mice cursors, can you? Is there any way I can highlight something on here?
Move it around. We might be able to.
No, I'm moving it around now. Okay. If you see that GPO and serial JST connectors box, that's arranged in the same order. Sometimes the silk screen on the BeagleBone Blue, fortunately because we crammed so many connectors in there, it's a little bit hard to read. This is a nice cheat sheet for that. That's actually in the layout of where those connectors are, and then the numbers for it. So which UARTs, if it's UART 0, 1, or 5, the GPS, the SPI ports, so that shows where those are on the different connectors. That's kind of a handy summary right there for you. So that's what you generally use in order to try to wire these things up, right? So you've got the DC motors. There's a little silk screen on there that shows 1, 2, 3, 4. They're numbered clockwise from the lower left, as well as the encoders are also numbered 1, 2, 3, and 4 around clockwise from I say lower left. It's the if we look here. So what I'm saying is lower left. There. So one of the first questions I think people are going to have when looking at this robot, and I hope you can see it fairly clearly, is how am I going to wire these things up with these JST connectors? These are pretty standard connectors. You can buy these breakout wires from a number of different sources, including folks like SparkFun sells a bunch of them, and we've got up on the GitHub site. If you go click on the wiki, there's links to a bunch of the different places where you can go buy some of the different accessories, including these breakout wires, right? So for putting together this Pololu chassis, I had to connect up these motors, and then I had to solder them to the motors, right? So I just had to solder the one side. So it's a quick connect on one side and solder on the other. I will go through more of the details of actually building the robot in the next webinar, right? So this one I'm just really trying to introduce you to the BeagleBone Blue and kind of show you the quick preview. We'll go to the details of how to actually build that up in the next one. All right, so but you can get an idea of where all the headers are from that one. And all the support for this is, I mentioned the librobotics cape earlier, so right, it actually just breaks it all down into these different C functions that you can include within your applications. So for initializing, there's some management to keeping track of the process ID. So there's kind of trying to keep one unique piece of software running. There's this initialize cape and kill robot. So kill robot will kill whatever process may have previously been utilizing the robot resources. And then cleanup cape kind of frees up resources for other folks to use, put everything back into an idle state. So you can do some state management between there, but like things, if I want to read the additional buttons, right? So there's a total of 5 buttons on the BeagleBone Blue. There's a boot button to force it to boot off of microSD. There's a power button to do a soft power down or power up. And then there's a reset button that'll do a hardware reset. But there's also 2 user configurable buttons. There's the pause button and the mode button. And those are really up to you to configure how you want to use them. There's nothing done in the system for it. It's just in your robot application how you'd want to use those 2 buttons. There's functions for reading the encoders, setting the DC motors, turning them to brake, turning them to free spin, or actually turning them on to various duty cycles. So you can turn them all on or turn individual ones on. And then for the servos, right? So you can set the servo positions. There's also ones for if you're doing ESCs. There's for electronic speed control. That's if you wanted to do these like the 3-phase brushless DC motors that would typically be used on quadcopters, hexcopters, octocopters. So all of those are possibilities with the BeagleBone Blue. So that's really where the programmer gets his interface, and that's all documented on the on Strawson Designs page. So we'll have that linked in the resources page, slide. But that's the set of functions. But there's examples for using all these functions. So there's a bunch of pre-built applications. So this is, I guess all the columnation got changed around. But this is some of those lists of functions. So I'm actually going to show some of those running on the robot. So if we'll turn our focus a little bit towards the screen that's my desktop, that's got my web browser running on it, right? So let me get my cursor back over here. So you'll see there's my desktop running my web browser. So this is the Cloud9 IDE, and it typically comes up. You'll see the workspace here, listing off the different files that are editable, and but I've just minimized that workspace, and I've opened up a little browser tab within the browser. So this is showing here. This is a URL for a service called. Why is it just slipping? MJPEG Streamer. So that's an application that you can install to work with a USB webcam. It's in our package feeds. So there we'll when we do the robot build, we'll provide some instructions on how to get that configured. But that allows me to actually use the USB host port to connect up a webcam, right? So what's being served in that window is actually is being streamed through the BeagleBone Blue itself. And you'll notice this is all not connected through wires. What I did is I configured my BeagleBone Blue to connect up to my wireless LAN. I'm getting disoriented and aiming here.
Yeah, the other way, Jason.
There we go. Right.
There you go. There you got it.
So yeah, so it's running off of a LiPo battery that I've shoved underneath the BeagleBone Blue. These are standard hobby LiPo batteries that come with the connector on them. So you look for 2S 1P LiPo batteries, and those will work. There's some listed in the accessories, again mentioned on the GitHub wiki. So that's there to power it. So I've charged it up. You see currently the status there shows that I'm at close to full charge on that LiPo, and then I'm using the Wi-Fi connection to connect to it. So it's actually broadcasting its host name on my wireless network, right? So I'll go back down to here and type in some things, right? So if we look at host name, so I actually changed this file. The default is actually going to come up as BeagleBone. So you would find it on your home network as beaglebone.local, and you would just browse to that at port 3:3000. So you'd add :3000. There's also a web server running on port 80 that would provide you some additional information, including talking about how to get into the Cloud9 IDE, which is what this is. But if you just browse to port 3000, and down at the bottom, you'll see the ability to add new terminals. So this is a terminal window that I've got here running. So that allows me to, that's directly to the Linux command prompt where I can type in arbitrary Linux commands. It's pretty flexible. All right, I can run essentially full text screen applications with that, even applications like VI here directly within my browser. Then we'll have the editor window. We can edit code. This happens to be the Blink example. So we'll see all these examples under the Azure Share. There's a template under user share robotics cape, and then the source code for the different examples can be downloaded from GitHub. So I've cloned this robotics cape installer, so you can get the source files for all the examples. And don't worry, there'll be links to that in the hopefully this is going to be recorded as well. There'll be links in the in the slides. All right, so that's.
Yeah, you could always access us as well if you need the links as well.
There was a question if the IDE is free. It is free. It's actually it's being served up by the board itself. The open source license is somewhat restrictive, so I know that there's some distribution limitations, and we have permission from the folks at Cloud9 IDE to redistribute this on our boards. But it's we're not utilizing any sort of cloud service here for this IDE. This is all just running on the board itself. Yes, it's free, and it's just it's a Node.js application that we've invoked on the board.
There was another question about
for
JTAG.
The blue, so the black wireless has a place where you can solder a 20-pin JTAG connector on it. With the blue, we actually removed that. We did include test points. If you want to do JTAG on there, you would have to solder individual wires to those test points, and then break out a header of your own. Really we think that if you need to do low-level debug or do some of those things, then there's the black wireless you can solder a header onto and those sort of things. We're really looking at much higher level development with the BeagleBone Blue. So while it's certainly possible to solder on and do a JTAG, no, we did not include any easy way to put JTAG connectors on it. But we didn't try to avoid it either, right? We put test points, but we didn't take out all the board space that it would require to put a full JTAG connector on there. All right. So let's go through some of these features, right? So we mentioned that there was DC. Well, let me just show this, right? So if I do RC tab, right, there's a list of some of the different. So now you know where the RC comes from. If you're using a BeagleBone Blue, right, it comes from the fact that it's the Robotics cape, but there is no cape involved here, right? It's all integrated into one board. So if you do RC tab, you get a list of some of these different default functions, right? So if I wanted to do say something like RC test, well, I don't know, the first one comes to mind is IMU, right? So that's what's going to give me, I'm going to hold it up here for the other webcam, right? So if you see, if I'm holding it up fairly level, if you know your basic physics, right, it's 9.8 meters per second squared is the force of gravity. Right, so you see that sitting around 9.8 meters per second. If we flip it upside down, now we're at negative 9.8 meters per second squared, right? And if we hold it on one side, we'll see in the x-axis is minus 9.8, and then the x-axis is positive 9.8. All right, and you can do the same thing for the y-axis, right? So that gives us our orientation. There's gyroscope. And so you can go and look at that example to see how you can go and read that inertial measurement unit. Right, and you can really quickly see that things are working on your system without having to build your own applications. Right, so we can currently see we're sitting somewhere about 400 meters above sea level here using the barometer. But we want to turn some motors. So if we run...
Yeah, make something spin.
Let's make something move. If we run the test motors app, right, it's going to give me a number of arguments that I need to provide, right? So I'm going to have to define what the duty cycle is, how fast I want to run the motors, and I'm just going to run all of them instead of just one individual one. But I'm going to go and have it sweep. I'm going to have it sweep fairly slow. So I'm going to do a sweep of, let's do 0.2, and we'll do all. There we go. Yay, motion. Hooray! It's live! Yeah. So that makes it really, really simple just to before you actually get into any of your coding, you can make sure your electronics and your mechatronics are working just using the command line, right? So it's nothing here. We're just on your computer. You didn't have to install anything. You just open up your web browser, browse to the board. I will note, I kind of backing up here, just something I kind of forgot to mention, is that this actually shows up as an access point here. So if you see BeagleBone -C338, you know, I'm not currently connected up through that because I want to get out to the internet, so I'm on my home network. But if I wanted to, I can actually log into my BeagleBone through the network that it serves up. The password is BeagleBone with capital B's. And then it's always going to be at a fixed IP address of 192.168.8.1. So that way I could log into it. So what I did is I logged into it that way, opened up the IDE, and then ran this thing called Conman's Control. You can Google that, and you can see that's, you know, you can see the different Wi-Fi networks and scan Wi-Fi and all that fun stuff. There's pretty much no end to the stuff I can show, so I'm gonna, if people ask some more targeted questions, I can actually focus in on those things. But otherwise, I'm just going to keep going around some of the key features of the board. Another one is the encoders, right? So if I have multiple motors on my robot, but if I actually want it to go straight, I'm going to need some type of feedback because you put the same pulse width, you know, variance on the different motors. They're not going to behave exactly the same way. No two motors are going to behave exactly the same way. So just putting the same strength is not going to make it go straight. You need some feedback, right? So here I'm using on this Pololu chassis, they've got a magnetic encoder wheel on the motor shaft, right? So you can see as I turn the motor, they can read back the position of the motor, and so that's critical for being able to actually do robot development. I'm turning the wheel on the far side so you can't see it quite as easily. Right, so built in, no special software configuration, just run the app, right? But then when I want to create my own application, use the use the C API to go and create my own applications. There was a question about what other development environments are available other than Cloud9. In general, for BeagleBone Black, quite a few things have been written about utilizing Code Composer Studio or Eclipse or a number of other development environments. You can always just SSH into the board, or log into the board, use VI, or if you want to install Emacs or whatever you might want to do. Those are possibilities because it's just a Linux system, so the world's kind of wide open to what you want to do. I point to the Cloud9 IDE because it's a zero install and type of environment, and it's somewhat easy to get going with. But really, any sort of development environment that you're used to, that you already have a preference for, it's likely that you can get it to work with the BeagleBone because it's a Linux system and standard ARM processor.
So we have like 10 minutes to go. So Jason, you'll continue, but we'll field any other questions that anybody will post as well. But we got like 10 more minutes to go. Okay.
Okay, I want to show one more, which is one more little bit of hardware that I've got connected here. So we'll see there's a 6-volt power rail that we can enable to turn on and control servo motors. You see I've got the little hobby servo. And I just want to again do a sweep of that. So here you can see it's just that easy to start playing with the hobby servo, right? And for those of you that really weren't familiar with DC motors versus servo motors, right? So servo motors are these ones that do the sort of back and forth, and DC motors are doing more of the free spin. The other major type of motor is a stepper motor that will use multiple coils to kind of lock the motor into discrete steps. And you could potentially use 2 of the DC motor drivers to drive a stepper motor, but we don't currently have any examples of that for now. But we're hoping to move forward with that. There was a question if there's a kit available or a parts list. All the components I'm using here are listed on the GitHub, on the wiki. If you go into the accessories, they're all listed there as to which ones I'm actually using here in this setup. And in our next webinar, we'll actually go into more details, actually going through building that up and writing an actual application to actually use this webcam and the controls to actually create a remote controllable robot where you can actually go and kind of give us some telepresence and go and roam around. And let me point back and jump to the last slide. I think there was some item that I've forgotten about earlier that maybe before I conclude, I wanted to bring up. I don't know, Ed, George, if you want to remind me, but if you don't remember, I'll go ahead and. So that LibRobotics cape that we were showing, if you go to strassendesign.com, ignore the steps we were talking about installing because you don't need to install from the BeagleBone Blue. It's already in the default images. But otherwise, all the documentation there about the C library and the examples, that's definitive. That's where you get that main source of documentation from and learn how to use that. In order to get the latest software images, go to beagleboard.org/latest-images or the short link bbb.io/latest. You can follow the links to the wiki to find even newer images, test images that are available as we're developing them. I really recommend that you just start with running it off of the micro SD card. So use a tool called Etcher to program it onto a micro SD card. When you want to commit that to the onboard flash, you'll have to edit a file in order to tell it to, when it boots, to write that onto the onboard flash. And you can find instructions for that on that wiki. in order to get into that Cloud9 IDE, there's some instructions on bbb.io/start or beagleboard.org/getting-started. That's where you'd find information on getting into the Cloud9 IDE. There's some documentation. I'm still working. I've been working on it today and yesterday. Still working on getting up there, but that page currently guides you through just doing it over the USB connection. But if you wanted to do that on the access point that it serves up, there's that magic IP address is the 192.168.8.1, and the password for that access point is BeagleBone. If you have any questions, if there's things that I didn't get the resources dotted down for, and you need to go and find that, here's the chat forum. You can come and discuss this with us. This is bbb.io/discuss or beagleboard.org/discuss. And you can get in touch with me and tens of thousands of other BeagleBoard developers to try to get answers to your questions. And I actually even, if you go to beagleboard.org/about, I publish my email address, a phone number where you can leave me voicemail, and you can schedule meetings with me even. The thing I ask is post questions to the forums always before contacting me. If you don't get a good response in 24 hours, then go ahead and contact me. All right, I want to be available to the community. I think that the answers, get out there to the community pretty quickly when you use the online forums, and that's really the best way to go in getting accurate answers, and the best answers in the shortest amount of time. But if you're not getting answers, then escalate them to me, and that's what I'm here for.
Excellent.
Any?
There's one question there, Jorge, I think. I think there's two questions. Easy to do OTA flashing. So
Two
develop
questions.
on my desktop and download to bot. That's the question. Well, you see it there.
For developing an application offline, I really recommend using GitHub. So just using standard Git tools, the GIT. So if you're not familiar with Git yet, I recommend going to learn.github.com and learning about Git as a software management tool, and really just syncing your projects to your computer as well as to GitHub or any other Git server that you might want to use, and then downloading those onto your board in order to propagate them out. If you configure one board in a way you like, there's scripts. I remember it was the Pinmux thing I was going to show you guys. If you look in opt scripts, there's a number of different things here, and including in the tools directory. If you looked at eMMC, there is a script in here called BeagleBone Black Make Micro SD Card Flasher from eMMC. That script itself is, if you run that, it'll actually copy the contents of the eMMC onto a micro SD card, and then when you boot your other boards off of that micro SD card, it'll write the contents to the micro SD card onto those boards. So that's one of the easy ways for deployment to multiple robots. Is you use that script to copy to an SD card and then install that into other boards. You can use tools like Etcher.io in order to take that SD card image and put it back onto your computer. We're talking about fairly large images here. Compressed, the image is about 400 meg for the BeagleBone Blue as it ships by default. The bbb.io links are not working. I'm curious about which one, because they work for me. So
Seems to be some sort of a redirect. That's what's happening.
yeah, there is a redirect. These are all my.
Yeah, because he.
Oh.
Oh, not from.
Okay.
Europe. Saying it's easier.
I'll try to look in the access logs if you can follow up with me about that. If you have JavaScript blocked, right, I am using the a Google library in order to redirect my short links, just to keep track of who's using my short links. So not who, but how much they're getting used. So I know what's. But I can, we can give you the direct links as well.
There was a question about using the BeagleBone as a
Yeah,
octo
a number
printer
of people do
to
that.
replace the Raspberry Pi.
The folks over at Aleph Objects, the guys who make the the Lulzbot Taz,
Taz.
the
Taz.
Taz Mini. So those guys, they're actually using it. They're using BeagleBones. They've got the mounting holes for the BeagleBone Black and BeagleBone Black wireless. I guess the BeagleBone Blue would work as well. On the Lulzbot. And they actually you do that in their own build farm. They're actually using BeagleBones for running Octoprint and doing that in their own build farm. And I believe they have a decent blog post write up about configuring Octoprint for that. So it's absolutely doable. There's also a number. I think what's more interesting is there's a number of capes for actually building 3D printers directly out of the BeagleBone, and even provide things like 3D previews with LCDs for what you're printing, and high-end interfaces and network interfaces. The one I would recommend the most at this point in time is the Replicape. So if you Google Replicape, you can find that. So yeah, that's certainly an option. I can wrap up here. I can show a few more things in SysFS.
I guess it's time to wrap up. It's we're at the 1 hour marker. It was very interesting. We are going to be hosting a part 2, Unleashing the BeagleBone, in which we'll get more involved with the actual BeagleBone, see it work, see its inner workings, and everything else. You want to let us know a little bit more? What do you like to talk about on the next one, Jason? To get them excited.
Yeah. So there's actually a couple of questions on the right now about that, right? So what I'm going to do is take this this build of this Pololu chassis, and I'm going to show you how to mount the web camera to the front of it and actually build a web cockpit where we can drive it around with a joystick on your computer and see in the web browser what it sees, and actually do the feedback so that it drives straight, right? So trying to avoid making it overcomplicated. There's a number of really great examples for things like building balancing robots and doing things more complicated. But I wanted to try to keep this one pretty straightforward and simple. All right, so we'll,
Yeah, that was really nice. Now we have a little bit of history of the BeagleBone and where's it come and how it developed and how it's evolved. So great information going on there. I think we've covered almost all of the questions that we wanted to cover. Jason, we thank you very much. We look forward to the next one. It was great, good information here. Anything else, all right? Okay, so thank you everybody for coming. We're going to make the recording available to everyone as soon as we've edited and have it ready to go. Any last words, Jason?
I just really appreciate everybody taking the time to join this, and hope they'll become active participants in the community.
Excellent. Thank you very much, everybody. Thank you for attending. Thanks for being here. Never stop learning. And thanks again. See you soon. Bye.
Bye.
Bye, Jason. Thank you.
Sure.